All right, so we're factoring, and you've probably been familiar with differences of squares for a long time. There are also differences of cubes and sums of cubes that we'll get to in a minute. And if you check any formula sheet that has factoring stuff on it, one of the things you'll find is a difference of cubes. It'll look like either a cubed minus b cubed, or in the case of the one I'm looking at, x cubed minus y cubed. And they say it breaks down as x minus y, x squared plus xy plus y squared. What does that all mean? Well, to use this at all, your first term and your last term have to have a minus between them, and they must both be perfect cubes, meaning you better be able to find a cube root for each of these. In this case, we're saying that the cube root of our first thing, the one at the front, is what? What cubed would make that? I'm saying 2x. Right? 2x times 2x times 2x would make 8x to the third. And for our second term, 3 times 3 times 3 would make 27. So when the expression says x and y are a and b, these are what they're talking about, the first root and the second root, or the root of the first term and the root of the second term, if you will. And it says the factorization goes like this. First minus second times first squared, that's 2x all squared, we'll deal with that in a minute, plus first times second plus second squared. Good. So we're not working with these two values at all. We're working with their cube roots. When I say first, I mean this one. When I say second, I mean that one. And if we clean all this up, we get 2x minus 3. Then we get 4x squared plus 6x plus 9. And that's probably as far as this will factor. You can try to factor this quadratic. It almost never factors, and if it does, it means there was a common factor up here that you should have caught sooner. Typically, when you get down to this point, this is as far as it's possible to factor, so hopefully that's enough. Let's see if we can do it again here. We're doing cube roots for each of these values, so what would the cube root of that thing be? It would be a 4w squared, and the second one is simply going to be y. Those are our two cube roots. So the first and the second cube root. And again, we go back to our factoring formula up here, or on whatever formula sheet you're getting used to. It should tell you that we do first minus second, 4w squared minus y. Then we do first squared, which means 4w squared, squared again, plus first times second plus second squared. I wish I'd made these square brackets from the very beginning to differentiate them a little bit. We'll do that now. And so our cleaned up version, 4w squared minus y, 16w to the fourth, plus 4w squared y plus y to the second, done. If you want to expand this, you should find you get 64w to the sixth minus y cubed when you're done. I'm not going to do it because I'm running out of space, and you can get some pretty good writer's cramp trying to write out all these things small and neat on a tablet, but it should work. It's worked before. Looking at our next one, this is a sum of cubes because these two terms have nice cube roots, and now we have a plus in the middle, and that only changes the factorization a tiny bit. If you look at your formula sheet, it should tell you that if you have a cube plus another cube, two of the signs change. You get x plus y, and then you get x squared minus xy plus y squared. Or your sheet might say a cubed plus b cubed, and then you get a plus b, a squared minus ab plus b squared. All good. So if we do that with this one, The first cube root is going to be 4a. The second cube root is just 5. So, according to our factorization formula, we get first times second, first plus second, square brackets this time. Then we get first squared minus first times second plus second squared. Clean that up. 4a plus 5, 16a squared minus 20a plus 25. And last one, another sum of cubes. Our first root is 2p. Our second root is 3q. So when we factor it, first plus second, 2p plus 3q. And then we get first squared minus first times second, which will be minus 6pq. I'm doing this one a little more compressed because you've probably got the idea by now, plus second squared, 9q squared. Okay, and with all the energy I saved doing that, I'm going to expand one of these and just make sure it really does work. If we multiply this out, we get 2p times 4p squared is 8p cubed. 2p times minus 6pq is minus 12p squared q. 2p times 9q squared is 18p squared. Now we go back and do the 3q. 3q times 4p squared is 12p squared q. You may have noticed those are going to cancel. 3q times minus 6pq is minus 18pq squared. Another cancellation. It looks like this is working on some level. And 3q times 9q squared gives 27q cubed. These terms are going to cancel out. These terms are going to cancel out. And what remains? Look at that. 8p cubed plus 27q cubed. It works.